A quadratic function is a function that is written in the form of f of x equals ax squared plus bx plus c, where a cannot equal 0. The standard form of the quadratic function is f of x equals ax squared plus bx plus c, when ax squared is your quadratic term, bx is your linear term, and c is your constant term. The condition a cannot equal 0 gives every quadratic function a quadratic term, but not necessarily a linear term or a constant term. So a quadratic can look like ax squared plus c equals 0, which does not contain the linear term, or ax squared plus bx equals 0, which does not have the constant term, or ax squared equals f of x, which does not have the linear or the constant term. If a equals 0, then the function has no quadratic term, which means it is not a quadratic function. And this is what happens when a equals 0. A parabola is the graph of a quadratic function. Parabolas are U-shapes, which would look like a rainbow or even a bridge. The axis of symmetry is the line that divides a parabola into two parts that are mirror images. In this case, we have the line of symmetry is x equals 2. The vertex of a parabola is the point at which the parabola intersects the axis of symmetry. This is the point where the y value represents the maximum or the minimum value of the function. Here we have the maximum as the point 2, 3, and we have the minimum as the point 2, negative 3. In this example, I have when the quarterback throws a football, the ball makes a parabola, and the highest point would be the vertex. This concludes our lesson on quadratic functions. I hope you have learned the three important parts of a quadratic: the vertex, the axis of symmetry, and the parabola. Speaking of the parabola, did you notice it in the picture? Have a wonderful day.